last but not least in this unit 7 point, let me just rearrange here, there we go, 7.7, identifying types of symmetry on the Cartesian. Remember, we learned that in Unit 6 about Descartes, the Cartesian plane. So let's just recap here. What are the different types of symmetry that we see in each picture? Well, if I were to draw lines of symmetry, that would tell me that we're seeing a lot of reflections. Like this, reflections. So we have line symmetry or reflections. But this guy right here, we're noticing that we have a rotational symmetry that's occurring. Today we're going to introduce another type of movement called translation. But before that, let's look at the image that we have right here. So on this grid, rectangle A has been rotated 180 degrees about the point E, which is right here, -1, 2, to produce the image rectangle B. So I'm just going to draw here. If we rotate it, we get an image. But here's the thing. It also looks like it's a reflection. Let's just keep on reading here. We can extend our meaning of line symmetry to relate to the two rectangles. In the line through -1 on the x-axis is a line of symmetry for the two rectangles. Each point on rectangle A has a corresponding point on triangle B, and these points are equidistant from the line of symmetry. So what we're trying to get at here is when the shape and its transformation image are drawn, the resulting diagram may show no symmetry, line symmetry, rotational symmetry, and sometimes both line symmetry and rotational symmetry. So some people are going to look at this and say, in fact, I think most people would look at this and say, this is a reflection, or this has line symmetry because it's equidistant from the line of symmetry here. I think a select few would say it's rotational symmetry, and it's rotated 180 degrees around point E, which is found at -1, 2. So very few. For me, I would say give your most simple answer. Don't look for the most difficult ones. Though, if you find it fun, finding all the ways that a different shape find rotational symmetry or line symmetry or exhibit those things, go to town, because that is definitely a compulsion that I want to support. But if you're feeling overwhelmed by the options, just look for the one that comes naturally to you. So let's use that when we do example 1. For each pair of rectangles, A, B, C, D, and E, F, G, H, determine how they are related by symmetry. So with A, what I would say is two options. If I were to pretend that this was like a flag, okay, and I would draw like this, what I would say is that quadrilateral or rectangle A, B, C, D is rotated 180 degrees. Now it doesn't matter if it's clockwise or counterclockwise because it's the same thing, it's just a line. Is rotated 180 degrees about. Now this point that's right in the middle, let's call this one Z. Point Z, which is found at 0, 3, to create E, F, G, H. Because if I were to take this and it's like a flag, and I would swing it all around, I would find that the flag, instead of facing up here, is now facing down. What about this one though? Well, I can say that A, B, C, D is reflected in the horizontal line through y equals 0 to make E, F, G, H. Okay, that's one option. But another thing is we can say that ABCD is rotated around the point (-2.5, 0) to produce this image here, EFGH. So ABCD is rotated around point (-2.5, 0), 180 degrees to produce EFGH. I would say that the majority of people are going to see this one before they see this one. And that's okay. This answer right here will give you full marks. You don't need to have both answers to get full marks. You just need to have one. What about C? Well, for me, I see a reflection before I see the rotations always. Okay, so I would say that A, D, C, D is reflected in the line through points. Let's pick one. (-6, 2 and (-4, 5) to create EFGH, because we have this point here becomes this point. We have this point here, which becomes this point. We have this point here, which becomes this point. And we have this point here, which becomes this point. So ABCD becomes GBEH. Oh, sorry, GFEH, okay? Because those are the corresponding sides, or the corresponding points of reflection. There's another one that we can say. We can say that ABCD, let's keep it capital here, folks. ABCD is rotated 90 degrees clockwise around the point (-5, 4). Because if we were to get rid of all these colors, if we were to do that, this A would correspond to F, and B would correspond to G, and C would correspond to H, and finally, let's get a fun color, D would correspond to E. Now again, I would probably say that most people are going to be able to see the reflection before they see the rotation, but that could just be me. If you're better at rotations than you are reflections, go for it. Answer in the way that that the rotation. But again, you just need to have one way in which the two shapes are related.